Hi, this is a video for week 10. Let's do it. Which theorem can be used to show that the two triangles are congruent? All right, so we have a side, an angle, and a side, right? A side, an angle, and a side. So I want side, angle, side, triangle congruence. Which composition of rigid motion cannot map one triangle on another? So two translations, that's not going to get there. So because a translation just means to scoot it left, right, up, down, or a little bit of both. And that's not going to work. I need to either rotate it or flip it over. A glide is scoot it and flip it. So that's not going to get there, but the other ones would get me there. All right, 3, find the length of EF, given the length AB is 20. So they don't look alike. So this kind of throws me off here. AB is 20. And this one has 1 mark, right? So I can set this expression equal to the 20. Okay. But I'm solving for the length of EF, so I got to be very careful here. In fact, I should have highlighted this a different color because this length is different. You see what I'm saying? That one's equal, and these guys are equal. Okay, so now let's solve for x. That might help me later, so let's go ahead and do that. So now I know the mystery of the x. X is 6 in this problem. So I have 14 and I have 14, right? Because they're congruent. So what is the length of EF? I get 14 and x is 6. Yep, that matches our answer. Nice work. 4, fill in the table to match the parts of the congruent triangles. So FD has 1 mark, AC has 1 mark. FD, AC. I don't see that. FDAC. All right, I'll add it. Now, what else? Okay, AB matches DE. AB matches DE. Okay. Angles. DEF. DEF is this angle. So it's on the other side of the green, but not the one that matches A and D. So it's got to be this one, right? So that's got to be, corresponds with angle B, and I can call it ABC. Okay, what about angle EFD? EFD. That's the angle on the other side of the purple. So that's got to be this angle C. So that is EFD. So across this side though. So I got to go BCA. BCA. All right. Unless this side that isn't matching will match FE. And the reason is because it's CPCTC. It's the corresponding part of a congruent triangle. So how do I know they're congruent? Besides the fact that they say it, they're congruent because of side, angle, side. That's what their evidence spells. Nice. Okay. Let's do a few more. It says, use the diagram for 5 and 6. Given 2 examples of pairs of sides, give 2 examples of pairs of sides that could be used to show angle, angle, side. Okay. So what they're doing is they're admitting right now that there's not enough evidence. Right now, there's not enough evidence. But if there was an additional piece of evidence, if we added it, it was going to spell angle, angle, side. So this is an angle and those are angles, right? And so I want to spell angle, angle, side. I don't want the side between, so I don't want this side, or that would spell ASA, right? So I want a different side. So if I picked the short side, notice this evidence would spell angle, angle, side, angle, angle, side. So that would say give 2 examples of pairs of sides. So if they told me FD is congruent to BA, that would work. Now what else? Now, if they actually told me the longer side matches, so that would also spell angle, angle, side, angle, angle, side. So if they alternatively told me CB is congruent to EF, that would also be, so that's a second pair of examples. All right, 6. If it is known that ABC is congruent to DEF, which of the following is not necessarily true? Okay, so it's usually just like ABC, DEF. That means A matches D. That means B matches E. That means C matches F, right? It also means these match, and these match. So let's see what matches here. A and DF. Oh no, that's not necessarily true. AB, first and middle, has to match. Oh wait, they did name this. Woo, there's a little curveball there. Okay, they named this DFE. Okay, so that one I like. First and middle matches first and middle. AC and EF, first and last. DE, oh, that's not first and last, so they went in a different order. I don't like it. Now let's check this. Angle C matches angle E. C and E are the last angle. Yep. Angle A matches angle D. A and D are the first angle. So we like all of these. This one will not necessarily match. 7, find X. So let's see. This is a side, an angle, and a side, an angle, and a side. So these are congruent triangles. So triangle ABC is congruent with FED because of side, angle, side. Now we can then say that BC matches ED because it's a corresponding part of congruent triangles. So that's why I can set these equal to each other to solve. And I just substituted that in, right? So subtract 17. And I get 8. Find X, I found it. Now I can plug it back in. Yep, okay. Yep, so my answer is 8. In the following figure, what additional information? So again, they're admitting there's not enough. So what extra piece would let me spell SSS? So I have one S matches one S, a second side matches a second side. So I'd need this third side to match the third side. So that would be CB. These two have to match those two. CB has to match EF to spell side, side, side. Let's take a look at 9. Which of the following pairs of triangles are congruent because of angle, angle, side? So these are all sides, so that's not going to work. I'm looking for angle, angle, side. This is all side evidence. This is two sides. That's SAS. So that's side, side, side. That's SAS. That's angle, side, angle. And this one's angle, angle, side. So we like D. Angle, angle, side. Angle, angle, side. Yep. D is our answer. What theorem can be used to prove that these two triangles are congruent if it is given that this is perpendicular and this is perpendicular? Okay, so if this is true, then this angle matches this angle. So that's an angle that matches. This side matches this side. And this is another angle that matches. So it's angle, angle, side. Angle, angle, side. Triangle congruence, right? Now, using CPCTC, we could set AB equal to DE. So we could say these expressions are equal, solve for X, plug it back in, and solve for the length there. But they just want to know the theorem. Why are they congruent? And it's because the evidence spells angle, angle, side. All right, 11. Find the value of X in the diagram and information in item 10. Oh, okay. So let's keep going. We're going to set these equal to each other. So AB is equal to DE, so I can say 2x plus 3 is equal to 6x minus 9. Right? And add 9. So I get 3. What's x? It's 3. Now we can plug this back in, right? So 6 plus 3 is 9. This would be 18 minus 9 is 9. So 9 is equal to 9. 12. Which theorem is not a valid theorem to show that two triangles are congruent? So we know our triangle congruence theorems are SAS, side, side, side. These are on the board, right? Angle, side, angle, 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 side, and HL. So we're going to be looking through to see if anything, oh, ass backwards, no. That's no good. That is not a triangle congruence theorem. So if that's what our evidence spell, we have to say not enough evidence. Nice work. Thanks for joining me for practice week 10.